Subasic, and I will give you a brief presentation about my PhD project. The project is conducted at KTH Solid Mechanics and is about corrosion fatigue in LVR environment at cyclic thermal and mechanical loads. My supervisors are Professor Bo Alfredsson, Adjunct Professor Paul F. Singh, Associate Professor Matthias Devander, and Dr. Jean Smith, and the project is funded by SKC, Swedish Center for Nuclear Technology. Corrosion fatigue in the pipe systems in nuclear power plants can occur due to the corrosive environment attributed to the LVR water, together with the cyclic loads, which can come from either the thermal fluctuations or the mechanically induced vibrations. The idea is to study the corrosion fatigue for Swedish LVR conditions for both PVR and BVR, and the analysis will be based on representative loads from CFD simulations and an intergranular stress corrosion cracking cohesive model. The overconservatism has been recognized in the ASME code for corrosion fatigue, which introduces a safety factor of 2 with regards to strain or 20 with regards to life. The overall research goal is an improved risk and life prediction method for corrosion fatigue in pipe systems in nuclear power plants. Some specific goals include developing an experimental setup for corrosion fatigue to perform microstructural analysis, and then based on these results, to model the degradation mechanism, and then finally to determine the environmental effect on fatigue, which will be very important considering the ongoing life extension of the nuclear power plants from 40 years to 60 years. The approach is to perform the corrosion fatigue experiments with hollow cylindrical specimens at Studsvik. You can see the hollow cylindrical specimen at the left picture here, and the testing machine at Studsvik is shown in the right picture here. Microstructural investigations will then be conducted at Chalmers on the corrosion layer, and then based on the results from the experiments and the microstructural analysis, some cohesive modeling of fatigue crack growth based on a cohesive damage model developed at KTH will be performed. And finally, the environmental influence on the fatigue crack initiation and propagation will hopefully be determined. Thank you for listening.